Hello everyone, my name is Sheng and I am a zoo chomp at Digizoo, which is a synonymous name for software developer. And what I'm here to talk about today are my experiences that I've done at one of our client sites, who's one of the most prolific buy now pay laters in Australia. And we are here to share the experiences of how we build a fully fledged fintech product within 10 months. So the subsequent slides what I'm going to cover will be approaches and decisions made by, not by me, but approaches that I thought are quite useful and quite impactful that helped us fast track a project success. So please note, all these approaches, they're not definitive, but they will, they actually work very well for our specific use case. So to give it a background of what we're building within the month of 10 months is an iOS front end on launch with a subsequent iOS front end post-launch. And then a BaaS integration, as well as internal and external service integrations, as well as leveraging an existing CI/CD platform. So pretty much we're building everything from scratch from day one. So how do we do it? These are 2 dot points which I'll cover, and these are what I thought are the very useful aspects. Backend for front end and daily deployment. Originally, I was trying to think of 3 cool dot points to think about because it's the rules of threes, it sounds so much better. But having done that through, I think it was only 2 that was needed because how easy it was to build a fintech. Okay, so let's start from the number 1, backend for front end. Why backend for front end? Or actually, I'll reword this question, why start from the backend? In my opinion, backend when you start from the backend, it's where you have the most autonomy because that's where you have the most control. It is also where you have most amount of the complex logic as well as the most complex business logic there. And in a case, it is almost a one-to-one replica of your fintech vision. So if you want to start developing, this is a Goliath where you should start from. So let's start from the backend problem. Fintechs have too much data. And that is getting worse with the advent of open banking. And it's also not just because of the quantitative amount, it's also the qualitative. And what I mean by that is you have a lot of sensitive data, such as PII and PCI data that's being exchanged. These data, and having worked from neobanks and integrated BaaS services, these data generally are stored in dedicated servers. They are separate servers that you have to query. It's different to a traditional database that you can access. So if you don't manage these properly, you can potentially have a mass amount of queries. You have cost, maintainability, and even potentially regulation issues. So how do you fix that? We have a data backend Graphql solution. I'm just going to give an example of what it currently looks like if you do it on a REST endpoint. So this is a typical REST call to get a data for a customer. As you can see here, this data response is immutable. But what happens if, say, the name, Luke Skywalker, is a PCI data or PI data? You know, you have to fetch a different, essentially say, call another BaaS endpoint to get that data. That essentially adds an extra call for every time you create this customer data. So what if you have a front end that actually don't need a name? You know, maybe it's for something different. It becomes a bit of a hassle and it adds your response time. Technically, you can also create a new endpoint that negates all that, or you have a very complex query that essentially specifies that only thing that you need. But I think it becomes unmaintainable and also it's an anti-pattern. So introducing GraphQL. Essentially, this is pretty much what it looks like. You query exactly what fields you want, and then in response, it returns exactly what you want. It allows versioning a lot easier as well because you can give or take depending on what you want. So just give a very quick summary. So between GraphQL and REST, GraphQL is a bit nuanced, and that's the issue. But because of that, it allows you for more leverage. It has a flexible response of what fields you want. It's all under a single endpoint, which is quite useful because in a typical REST implementation, you might have multiple endpoints, and that actually can become quite unmanageable if it's not done properly. And as I've covered before, ease of versioning does help a lot as well. And the second part of the backend problem is with our situation, we're developing the front end and back end concurrently. And that's a bit of an issue because I want to use a train analogy for this. So if you want to consider a backend is like an engine. An engine runs and it handles all the logic. The front end is more like the cast and the carriages around it. And that works perfectly in this analogy, but the issue is when you start running and developing both sides concurrently, it's like running that train down the tracks at full speed while you're still building it. well, it's going to crash if you don't do it properly because you have so many moving parts, the integration becomes increasingly complex. How do you navigate around this? Well, in my opinion, what we did is we followed the mantra of do everything in the backend and smart backend, dumb frontend. The idea of this is we try to decouple the front end and the back end separately. What the front end does is that it's simply, the only thing you have to focus on is be pretty. And second thing, actually, there's two things. The second thing is use the backend only as a proxy to any other external integration services. So you can see that for every other call that we need, we call the backend first. And number two, the idea of centralized implementation. So by doing everything in the backend, you have all the logic that's complex and business case in the backend, and you do not have any logic that's obfuscated from the front end. So you never have to have the idea of, say, like an Android team asking an iOS team, going, hey, how did you do this implementation on this side? You don't have to do that. The only thing you have to focus on from front end, just be pretty. And to further hammer in this idea of smart backend, dumb front end, I wanted to introduce you deep links. So the idea of deep links, which you might be familiar with, is say when you get a messenger notification from your friend, you say, hey, I saw this really cool YouTube video, and it's a link. You click on that link, it actually opens up your YouTube app on your phone. This is an example of deep link that orchestrates the app flow. So what this does is essentially having the backend orchestrates the complex flows that otherwise the front end will have to do. This one thing, it works really well because when you have business logic that's coming from the backend, you have this orchestration that is very simple. It's a centralized idea that without you don't need to have any implementation in the front end. And number two, it also further decouples having that extra logic in the front end as well. Just to give an example of where the deep links was very helpful was imagine the week before of our official release, we had a bug in the front end. It was a onboarding bug, which essentially accounted for about 30% of all the onboarding. But the problem was we've already submitted our app to the App Store and it's already approved. So the issue now is if we fix the bug in the front end and redeploy and push it back to App Store, restart a review process, we might not make it for the app launch. So you can imagine the tension in that room as we consider, are we about to delay our product launch or are we going to release on a day with 30% less users? But ultimately, what we realized is that we can actually re-orchestrate all that, the onboarding flow, which is quite complex, and navigate and essentially divert by fixing the front-end bug and to essentially, prove to us to be a successful product release. So that was it for the front end, and I want to talk about the deploy. So this is, I think, in my opinion, the hardest part of any product. Because once you build the front, you build your app, you build everything, you put it into product, you put it into production, and now it gets tested. And the thing is, it's going to break. Everything's going to break, because that's the idea of any product. You don't have a perfect release, at least not from my experience. And that's fine. And the idea of this is you want to deploy daily. What happens is you want to deploy daily. So I want to do an analogy here. It's like mastering any skill. It's about the frequency that you do it. So I've got a parable that I read about. It's about a story of a ceramics teacher. A ceramics teacher who, at the start of the semester, he told his class that he is going to mark the class differently, and he's going to split the class into two groups. There's Group A and Group B. For Group A, the ceramics teacher told the students they will be marked solely and graded on the amount of clay pots they make. So for 15 clay pots in that semester, they'll be graded A. For 10, they'll graded B, and etc. And for Group B, what he told the group is that they will be marked solely on the product of one clay pot they produce. And if it's perfect, you'll get an A, and for each imperfection, their marks will be reduced. So fast forward to the end of the semester, one will imagine that Group B, whose idea is solely to create the most perfect pot, will essentially create the best pot, right? No, it turns out it's Group A. Because the idea of this is that for them, it's a trial and error. They iterated towards building the perfect clay pot, and eventually they did. And that's the idea of what the story is talking about. It's all about not starting from perfection, but it's about aiming towards it and iterating towards it. And that's the idea of why I think deploying to daily works. So why should we deploy to daily? Number one, it makes your product way more iterative. You can build things very quickly. You can test features quite quickly. And for the engineering side, you build a quality. Because you don't really learn anything unless you fail. You don't live your days on the days you live. You live the days, or on the days where you're struggling to fix a production issue. Those are the days that really test you. Number two, you get immediate feature feedback, because if you do want to test something, even from product's perspective, you go, hey, I have a cool idea, let's do this right now. And you can. You do something real quickly, it goes in production. Obviously, there's a bit of QA process going on, but you can test it. You have engineers, you have daily deploys, you have fast bug turnaround times, because everyone's so familiar with fixing product incidents. From a product's perspective, you get product visibility because, well, if it's merged, it's in prod. That's it. Engineers, you have a code accountability because with a one press of button from essentially merge, your code is on the customer's hands. And this actually builds so much confidence in the engineer, and you actually care about the end product. Because, and I think that's one of the biggest things about having a good engineering team is that the engineer has to care about your product, and and that's how you build a proactive team. And last part, when you do something frequently, it's actually less stressful. Personally, I've never had a successful prod release, and there's always so much stress about having, because of all these changes that it's so stressful for everyone involved. But when you're doing daily, it's actually pretty easy. So I'm just going to go through the flow that we took when we deploy into production every day. So as soon as the code gets merged to production, initiates a build. It's done on build kite and it starts building all the way to staging. Once it's finished to production, once it's building to staging, right before production, it notifies via Slack that, hey, a build is ready for production. And once it's done that, a engineer who's not you can review the code differences between your local and your prod. And once they've deemed that image, bug-free, they can initiate that prod. And once it's fully deployed and successful, you get notified by Slack again. So just an example of what that looks like, what we have is a Slack message that's automated saying, hey, a new code is ready to be released. You can click on that diff and to see the differences between the code. So what happens, this is to make sure that no one's on top of each other. If you are reviewing a code release, you can react to that message to show that, hey, someone's on top of it. So, and then afterwards, you see that someone else other than Sheng has authorized the deploy, and this deploy was successful. And this is what the image on the build card looks like. As you can see, these are all the steps that we did, all the way until to prod. You can see that red arrow there is what you click on to essentially initiate that prod deploy. I want to highlight another button we have here, which is rollback production. So this is a rollback image function that we have, which essentially allows us to reverse back to a previously healthy image. Another thing I want to point out on this image is that it only took us 20 minutes to merge from merge to deploy. Okay, and another kind of thing I want to highlight is database migrations. Database migrations are a bit different to traditional deploys because they are generally irreversible, and if you do cause issues with your release, it's a lot harder to reverse that image. So we have a little extra image there, just like text there to show that, hey, this is a database migration, please be careful. Okay, so now what are guidelines when we deploy into production? We have feature flags. The idea of feature flags is if anything new that you have might break production, any new features that is not approved by QA, and you don't want it to be accessible by anyone in production, feature flags. Number two, you have small pull requests. This is just like a sanitization thing, but if you have small pull requests, it's easier to review from your perspective, as well as other engineers, and it actually makes your releases to production are much cleaner. It's easier to debug problems if you do break something. You can't deploy your own code. This is something simple, but you don't want an engineer going rogue and start deploying code themselves. And the idea of this also is that it trains your team to be familiar with other codes that is already existing in production. It's a very good skill and information sharing process. Image rollbacks. I've covered this previously, but this is like a very nice kind of undo button if you ever do stuff up. Beware of database changes. As I again said, it's irreversible. Well, generally, and you don't want to do that. And last part, liberal prod reaccess. This is something that I think teams should think about, is that you should trust your engineers. Your engineers should be able to access prod and should be able to fix any bugs that they want, but obviously you do want to have guidelines. So you do want to have auditing. You don't want, so that engineers, obviously, on average, they're generally well-mannered, but obviously you do want to track that auditing of their prod access. And another one, this is a big one, I think. This is probably the best thing you can do. And repeat after me is no deploys on a Friday afternoon. Some people want to go fast, but some people want a good weekend. Okay, so I'm just going to talk about some data we have for deployment. This is a DORA metric. It's a DevOps performance metric that people use. So you can see on the graph on the right-hand side, it's a data set which I picked up on a random week last year. It shows all the commits, deploys, and the errors of the deployment for that week. As you can see, a lot of the things we did over the weekends or on last Friday, it's actually all deployed on Monday. So that's an interesting thing. But lead time to change, so that's the time it takes from a Git merge to be deployed to production. It's generally around 25 minutes on average. The median's a bit lower. Deployment frequency, we're averaging about 8.4 deploys per day, which is quite nice. Mean time to restore, so this is the time it takes pretty much to fix a production incident. Image rollbacks generally are a bit quicker, about 3 minutes. As feature flag, it's even quicker to fix. And change failure rate, 2.4%. So this is for this specific data set. I'm actually lucky that there was errors. Previous weeks, there weren't any errors for this. But out of 42 deploys that week, there was one error. So it accounts to 2.4% of the failure rate. This slide, I want to talk about how if you want to go down this path of deploying daily, you need to have your team behind you. You need to have everyone on top of what they're doing because you have to have, the only way to do it is if everyone's agreeing to this decision. Because if you don't, what happens is you have a dumpster fire that's always burning in production, and each deploy just adds more gasoline. And it brings this adage of, if you want to go fast, go alone. If you want to go far, go together. And I think that's a very apt way of deploying to production. But yeah, that's it for me. I'm essentially reusing these slides from previously, but the idea is you want to deploy daily and you want to do it from back end for front end. Thank you, everyone.